Here we have the homework solutions, homework 17, and first question we have an expression, and the way we can tell an expression is it has multiple terms and no equal sign. Let's just highlight these expression terms. We've got the first one here, the 2y, we have the plus 6x, the minus 4x squared, and the minus 7. So there are 4 terms in this expression. What's the value of the constant? Well, the constant is the number on its own. So this one here, and that is -7. And the value of the coefficient of the x term. Now the x term is this one here. So not the x squared term, that's the x squared term, but this one is the x term. The coefficient is the number in front, and that is a +6, but we just need to write the 6. On to question 2, solve the following equations. Let me just rewrite this a little bit bigger. So we've got 5x is equal to 20. Now the first thing I want to do here is to eliminate this 5. So I'm going to divide both sides by 5. So divide by 5 and divide by 5. We get that x is equal to 4. The second question, we have 4x minus 5 is equal to 15. The first thing I need to eliminate is this -5, so I'm going to add 5 to both sides. When I do that, I get that 4x is equal to 20. And then I need to divide both sides by 4, so divide by 4, divide by 4. I get an answer that x is equal to 5. For question 3, we're asked, what is 12 as a fraction of 52? Well, we'll write that as a fraction first, so 12 over 52. We now need to give this in its lowest terms, so cancel everything. Well, notice that both of these are even numbers, so I'll halve them, so that's 6 over 26. Still even numbers, I could halve them again, so that would give me 3 over 13, and there's no common factor for 3 and 13, so that is the final answer, 3 over 13. Question 4, convert 0.26 to a percentage. Well, 0.26, what I can do is just write 26, so just ignoring the decimal. I then write it over 1, and I count the digits after the decimal point. Well, a digit here and a digit here, so 2 zeros. 26 over 100, well, that is 26%. On to question 5, and we have to simplify the ratio 36 over 39. Okay, well, we're going to divide both of these numbers by 3. So 3 goes into 36 12 times, and 3 goes into 39 13 times. And that is the simplest we can make that ratio. On to question 6, we've got the number of red, yellow, and blue marbles in the ratio 2 to 3 to 5. And we've got 12 red marbles. So the first thing I want to do is just to write red. We have yellow. And we have blue. Now I know those are in the ratio of 2 to 3 to 5. And we're told we have 12 red. So I'll write 12 down here. Now how do I get from 2 to 12? Well, I have to multiply by 6. So for each of these other 2, I would also have to multiply by 6 and multiply by 6. So 3 multiplied by 6 is 18, and 5 multiplied by 6 is 30. So we can see we have 12 red, 18 yellow, and 30 blue marbles. So we have in total 12 plus 18 plus 30. Which is 60, and I should have actually just finished that off with a sentence saying that there's 60 marbles in the bag. For question 7, we are simplifying the expressions, and if you recall, I said to highlight like terms. So we've got these like terms here, so the 3x subtract the 2x, so that will just be x. I've got the -4y, and then that -2 there, and that's the final answer for that one. And on to B, again, like terms. We've got all these m terms here. They're all like terms. 9m plus the 3m is 12m. 12 minus the 4 is 8. And 8 minus the 2 is 6. So we have 6m plus that constant of 7. Question 8, we've got to multiply x by 7, then subtract 8, give an answer of 19. It says write the following using algebra. So no, we're not solving this, we're just writing out the equation. So x multiplied by 7, well that is 7x. We're then subtracting the 8 to give an answer, well that equals 19. For question 9, we're solving the following using a backtracking method. So we're starting with the x term. The first thing we're doing to x is multiplying it by 3. We are then subtracting 4. That gives me an answer of 11. Let's work backwards. So we've got 11. We're going to add 4. We are then going to divide by 3. And that should give us the answer. So 11 plus the 4 is 15. 15 divided by 3 is 5. Final answer. Question 10, solving these equations. I'll just write it out a little bit bigger. So we've got 2x minus 1, that's over 7. We're subtracting 2 to equal negative 1. Now the first thing I need to do here is to eliminate the negative 2. So it's this negative 2 that I am eliminating first. And to do that, I've got to add 2 and add 2. When I do that, I'm going to get that 2x minus 1 over 7 is equal to 1. Now the next thing I need to eliminate is this 7, and to do that I'm going to multiply both sides by 7, so multiplied by 7 and multiply by 7. These 7's will cancel, leaving me with 2x minus 1, and 1 multiplied by 7 is just 7. The next thing to deal with is this negative 1, and to do that I'm going to add 1 to both sides, so add 1 and I'm going to add 1. When I do that, I'm going to get that 2x is equal to 8. Finally, I'm going to deal with the 2, and to do that, I'm going to divide by 2 and divide by 2 to give me an answer of x is equal to 4. Now on this next one, part 2, I've got 3 terms here, and I notice I've got a 3, a 6, and a 3. So the first thing I could do here is divide everything by 3. So divide this by 3, divide this by 3, and divide this by 3. Now when I do that, I will have x minus 2. The 6 divided by 3 is another 2, so that's plus 2, equals 3 divided by 3 is 1. Now the negative 2 and the positive 2 here, well, they're going to cancel. So what I'm left with is that x is equal to 1. Okay, on to the next question. Well, it might be worth pointing out as well, you could solve each of these by using a backtracking method, so that's perfectly valid. On to question 11, and we've got one of these Ben, Ken and Len type questions. And if you recall, I said look for the youngest person or the smallest thing. In this case, it's Len, he's the youngest, so we're going to say let Len's age, and we'll let his age be x. And therefore Ken is 3 times as old, so Ken is 3x, and Ben, well, he's 12 years older than Ken, so he is 3x plus 12. Now the sum of their ages is 82, so we have x plus the 3x for Ken plus the 3x plus 12 for Ben. That is equal to 82. Now we can simplify that a bit. We've got 7x plus 12 is equal to 82. So we have an equation we can solve. First thing is to subtract 12 and subtract 12. That gives me that 7x is equal to 70. And then we just need to divide by 7, and x is equal to 10. Now, I know a lot of you would probably stop at this point thinking, hey, I've solved the equation, but you haven't answered the question. The question says to find the age of each person. So we now need to substitute x equals 10 into Len, Ken and Ben's ages. Well, obviously Len is just 10 years old. Ken is 3 multiplied by 10 is 30, and Ben is 30 plus the 12 is 42. Now you should finish with a sentence for each of those, so remember to do that. I'm not going to bother, I'm going to move on to the next question. Question 12, convert 2/5 to a percentage. Well, 2/5 is the same as 4/10, so just multiplying both the numerator and denominator by 2, which is 40/100, multiplying both by 10, which is 40%. Question 13, we have to calculate 1/7 plus 2/5. So 1/7 plus 2/5. We have to get a common denominator. And the way we do that is to this first fraction, the 1/7, we're going to multiply by this 5 here. So what we get is we're going to multiply by 5 in the numerator and multiply by 5 in the denominator. For the 2/5, we're going to multiply by this 7. So I'm going to multiply by 7 and multiply by 7. And that will give me a common denominator. So 5 multiplied by the 1 is 5. 5 multiplied by the 7 is 35. Plus 2 multiplied by 7, 14. 5 multiplied by 7 is 35. And then we've got the 5 plus the 14 is 19/35. For part 2, we've got mixed numbers, so we need to convert to an improper fraction. And the way we do that for the first one, we've got the 2 whole number and 1/5. So we do 2 multiplied by 5 is 10, plus the 1 is 11/5. And we're subtracting the 1 multiplied by the 3 is 3, plus the 2 is 5/3. Now we need to get a common denominator. So for the first fraction, I'm going to multiply by this value here, 3. So multiply by 3 and multiply by 3. And for the second fraction, I'm going to multiply by the 5. So multiply by 5 and multiply by 5. When I do that, obviously the 3 times 11 is 33 and 3 5s 15. I am subtracting the 25. Final answer therefore is 8/15. On to question 14. We've got to write 0.2 as a fraction. Well, 0.2 is 2/10. Now we can actually simplify that to 1/5. Now, and then we start with that 2/10 again. 2/10 is the same as 20/100, and obviously that is 20%. For question 15, we have to do some simplification. So what I'm going to do here, I'm going to write this in like a long format. So I've got the 24. The x to the power 5 means we've got 1, 2, 3, 4, 5 x's. We then have 3 y's, and that's all over the 4x cubed. So that's 1, 2, 3, and then we've got 2 y's. Now what I can do here is start to cancel. So cancel 2 of these y's with 2 of these y's. I've got 1, 2, 3 x's with 1, 2, 3 x's. 24 divided by 4, well, that would give me a 6. So what we have left is 6. We've got these 2 x's here, so that's x squared. And we also have this y here, so 6x squared y. And similarly for the next one, we have a 2, we have x, x and x, y, y and y. That's all over 8, and then we've got 3 x's, and we've got 4 y's, 1, 2, 3, and 4. Let's cancel what we can. So 1, 2, 3, and 1, 2, 3. The 3 x's would cancel with the 3 x's. Common factor of 2 here, so 2 goes into 2 once, and 2 goes into it 4 times. So what we're left with is, well, just the 1 on the top, and then we've got the 4, and we have this y here. So 1/4y. Just be careful on these, on this one in particular, because you're finding a common factor here. What number goes into 2 and into 8? So when you cancel the 2 and the 8, don't say that there's nothing on top. There is. It's 2 divided by 2 is a 1. Okay, on to the last two questions, and these are slightly harder. These are definitely A standard questions. We've got to simplify A over B plus C over D, so we're just simply adding two fractions. Now, if I had two fractions, let's say I had 1/5 plus, let's say 2/3. How would I add those fractions? Well, I know I would take this denominator here and multiply the second fraction by that denominator. So multiply by 5 and multiply by 5. I'd do a similar thing for this fraction. I'd take that 3 and do a multiply by 3 and multiplied by 3. Now all we need to do is do a similar thing with the letters. So let me just write this a little bit bigger. So we've got A over B and C over D. So what I would do, I would take the B, I would multiply this second fraction by the B. So multiplied by B, multiplied by B. I would then take the denominator here and multiply the first fraction by the D. So multiplied by D, multiplied by D. Now when I do that, I would get A multiplied by D, so AD, over the B multiplied by D, so BD, plus the B multiplied by the C, so BC, and the D multiplied by the B, so BD. And I can write that as AD plus BC over BD. On to the final question, question 17. We've got a two-digit number where each digit is different. Swap the digits round to get a different number, then subtract. And why is that result always a multiple of 9? And again, I'm going to start by just using some numbers. Let's say my first digit is, 25. So a 2 and a 5. We know we've got to swap those numbers around. So that would give me 52. And I need to subtract them. Well, let's subtract using the bigger number first. So 52 and then with 25. And if I was to subtract those, I would get 27. And you can see that 27 is a multiple of 9. So why does that work? Well, let's have a look at the first digit. So the first digit in our case was a 2. But it's not actually 2, it's actually a 20. So it's 2 multiplied by 10. So instead of using numbers, let's use letters. Let's say let the first digit, and we'll let the first digit be A. And then we'll let the second digit, be B. So if I think about this, the 2 was actually 20, so it's 2 multiplied by 10. Well, the 2 in this case is going to be the A, so it's going to be A multiplied by 10, which is 10A. The B would be the 5, so 10A plus B. And you think about that's what we're doing. We're doing the 2 multiplied by 10, that's 20, plus the 5 gives us the 25. Now, if we reverse those digits, the B is now this one. So that's B multiplied by 10, so 10B. And then we've got the 2, which in our case would be the A, so it's 10B plus A. The next thing we need to do these is subtract them. So what I would have would be 10A plus B minus, and I'm going to put these in brackets, it's 10B plus A. So I'm subtracting the second number, and the second number is represented by the 10B plus A. Now when I look at that, I've got the 10A plus B. I need to expand this bracket, so I've got the minus 10B, so minus 10B. I've got the minus A, so minus A. Let's simplify this. We've got 10A minus A, which is 9A, and I've got a B minus a 10B, so that's minus 9B. Now what I can do here is I can do something called factoring out the 9, so I've got a 9 multiplied by A minus B. Now it doesn't matter what this bracket is, I know these two numbers are different because I'm told that. So I'm going to get a number in that bracket. And that number multiplied by 9, well, clearly that is always going to be a multiple of 9.